The talks I've given about Exposed before, the Kotlin SQL library, one of the first things that I've always done is introduce the table object from the library's core DSL. How to build it, how to set up a database connection, how to open a transaction, the basic steps. I recommend that you check out those previous talks from the first two Kotlin cons if you want a full-length introduction to Exposed, because this time we're going to be going fast and we're going database first. But what database? I'm going to take a guess that there is a good amount of you that have heard of John Conway's Game of Life project before in some capacity. And if you haven't, it's a 0-player game, a cellular automaton, and it's been researched extensively for its emergence and complexity behavior. And the app that we're looking at today is just a desktop simulator sitting on top of a database of patterns that have been classified by the project. It loads the initial state of cells and runs through each generation based on a chosen rule for whether a cell advances or is born into the next generation. Now, I don't want to hypnotize anybody today or give anybody eye strain, so the actual focus of this talk is not the sim. It's actually what's going on behind this data analysis screen. And of course, it's about Exposed and what we've been working on since we published the first stable release this January. We're actually at 1.3 right now. And spoiler alert, the majority of what we've been working on involves the word plugin. So we have an existing database of patterns. Now let's say that we wanted to build this app fresh. We could start exploring our new data in a couple different ways, but today we're going to go directly into IntelliJ. Technically, we're going to go right into the database tool window. So we have an active database running. It's got 4 tables. Hopefully, yes, you can see that. We've got a table for the individuals who've contributed to the patterns. We've got a generations table that is empty for some reason. We have a patterns table, and it's a big one, and it stores initial cell state. And we've got a table for rules. So those are the rules that you apply to each cell in a pattern to determine whether it makes it to the next generation or not. Now, I could open up a file, and I could start typing out our tables. But the truth is, I have the IntelliJ Exposed plugin installed. And one of the new features that it comes with is that we don't have to do that at all. We can just go in and use this new action, create exposed entities, and it will generate all the database tables for us. So how does it work? We go in, we say where we want the new files to be generated. We select the tables that we're interested in. We can, of course, do everything from choosing a new name. We have the columns in the tables, and we can actually choose a different name for the object property that maps to that column. Of course, we could go in and change the underlying data type mapping for each column. That is bright. And of course, if you have tables that have foreign key constraints, for example, there's extra options that we consider to go through that. And just like that, we have all the tables that we would need. Let me get rid of that. We have all the tables generated based solely on an existing database table. And if you're wondering why there's 8 files instead of 4, that's because the plugin is a little bit eager right now, and it actually generates the entity classes necessary if you were using data access object approach, for example. And that's just the more lightweight abstracted alternative sitting on top of the core DSL. And if you had started, for example, with these original tables, you would also have an intermediary step where you could create, on an individual basis, each entity class. So now that we actually have all of our tables set up, let's say that we wanted to actually start writing queries. And there's a lot of queries in the source code, from basic joins to window functions on CTEs, and all of them are used to build this data summary screen. And these plots are exposed queries built on top of features from the Kotlin DataFrames and Kandy plotting library. And there's a lot to go through with these plots, but what they all have in common is this handy convert to data frame function. So what we have here is a Kotlin, as an exposed DSL that's helping us build a query. We start with a join between two tables. We are selecting two functions. One is a concatenation function, and one is a pattern count function, and we're adding extra clauses. And the convert to data frame extension function triggers the query being sent to the database and automatically wraps the results in a convenient data frame for us to use. And what this means is we can keep our exposed queries clean, simple, and reusable for other parts of our code, but we can continue to post-process our data as much as we want. For example, we could completely rename all of our result columns, recase them. We could add an entire new column, maybe using data that we previously did not want to introduce as a query, as a root parameter, and we can filter some more. So now we have this versatile bridge between our exposed queries and our Kandy plots. And this is just a way of me highlighting one of our sister libraries, but it's also a way for me to highlight this guy right here, pattern count. So this is the DataFrame compiler plugin working to automatically generate type-safe extension properties that match and access the columns that we originally selected in our exposed query, which is really cool when you think about it. And to us, it's also really cool because we would love for Exposed to have something similar as well, which is why we are actively prototyping our own Exposed compiler plugin to provide across the board improved type safety and also especially reduce manual boilerplate through code generation. So the options we've tried so far have not fit, which is why I'm not up here unveiling some magnificent compiler plugin, but we want to make it very clear that this is something we are actually investigating on how to best deliver. So please, tune in for information for that over the next year. Another maybe slightly more common combination on the back end is, of course, Exposed with Ktor. And in this app, Ktor is naturally doing a lot, but Ktor is also helping us handle some heavy requests so we can take the data visualization that we saw a step further. If you go back into our app, all these plots that we've seen are static data that's queried and cached the first time the screen is accessed. If we go back, we actually see that we have quite a bit of patterns to choose from. So if we picked, for example, all patterns stored in the database, if we go in, we choose a new rule, maybe hopefully it's not too soon for anybody if I pick virus. We're gonna unpick the original one because technically we could choose up to 3 rules at a time, and we're gonna run that. So just to step back for a second and clarify what's going on here. If you remember that empty generations table that we saw at the beginning, what we're doing now is we're using it to store temporary generational data for every pattern, for every generation that's running on this rule, kind of like to actually visualize the birth rate of cells per generation, like a simulation of real life incoming data. But what we actually have happening on the back end is that we have a trigger on our database. So technically it's on the insert, but on our end it's more on the upsert into the generations table. We have a dedicated connection separate from our pool that we're setting up to actually listen to the notifications sent by the trigger. This is the only time in the back end that we are not relying on Exposed built-in transaction management. We're actually taking control and using a lower level connection so that every notified change from the database is pushing events to the client using Ktor's server-side event routes. And of course, there's one on the HTTP client that's listening in for any incoming events. So now that we understand what's happening there, what does this mean potentially? We have a bridge between our exposed queries and our Kandy plots. We have Ktor routes that handle a lot of data. There's a lot of potential for what more we could do with this data. For example, looking at the plots, which is still running, looking at the plots, we are currently only looking at life. What if in the future we wanted to observe not just births per generation, but deaths per generation. So what that would essentially mean is we want to look at the total change state of cells per generation. And in the game of life, this is called the heat of a pattern. So we're at a point where we're potentially considering migrating our schema. And Exposed has always had migration methods available for the programmatic generation of SQL scripts and schema validation checks. But with our most recent release of 1.3, we also published a Gradle plugin to simplify the process. So you don't need to customize your own Exposed migration workflows anymore. All you have to do is add the plugin dependency and configure it in your build file. At the moment, it has a single task, generate migrations. At minimum, you need to provide exactly where you're going to find the Exposed table definitions. You need to provide a way to access the existing schema. I've chosen to use test containers, but you can, of course, just provide the regular database connection properties. Test containers just gives us a little bit of extra assurance that we're using the most up-to-date schema, because it actually goes in and checks to see the existing scripts that you have, it runs them, and then it actually creates the scripts based on those that exist. And of course, there's multiple optional configurations to take into account, like which file directory you're using for the migration and different ways to format the version and the name of your file. So let's see a second. So like I said, it has a single task. You can incorporate it into a part of your build process. For us, we're just going to run it. And of course, if you wanted extra control over the file name, you also have the option to pass the file name directly as an argument to the task. And this will override any kind of additional configuration that you've set up in your build file. And of course, this is going to take forever because I'm on stage when it shouldn't be. But we are getting there. Thank you. So as you see, we have a new file. It has the expected alter statement, and we can apply it in whatever way we've already got set up, whether it's Flyway or directly using our database tool window. So if you are already using migration utils to generate scripts, please consider trying the plugin. Let us know how it goes. If you do try the plugin and you have thoughts about extra features that maybe you would like in it, off the top of my head, maybe, for example, that database first exposed code generation functionality that you saw in the IntelliJ plugin, maybe you think it'd be valuable to have it without the IDE. Don't tell IntelliJ. Let us know. You know, the more that we know, the more we can deliver. And of course, if you've been using V1 of Exposed and you've maybe found us at the booth, we'd appreciate any feedback from it. We always appreciate the community's feedback. You still have time to chat. So thank you for listening to this speed run of what's been happening and what's new and what's coming with Exposed. And I hope you all enjoy the rest of the conference. I guess I have time for questions, maybe.